and welcome to Cycle 2, Week 5. Today we have two experiments. Each of them have a slightly deeper or slightly harder subject to understand, so you definitely want to look ahead, read the explanations before Tuesday morning, and that will help you get an idea of how you're going to talk through it. The first experiment, number 16, called In and Out, refers to things that orbit other celestial bodies in the universe. So it could be referring to a satellite, again, like we talked about in week 1, where a satellite orbits around the Earth, or how moons orbit around planets, or it can be referring to how the planets actually orbit around the sun. The idea that you're trying to get across here is the concept of centrifugal force pulling that orbiting being in so it doesn't float off into space, and also the idea that the forward motion of that orbiting being keeps it going and is what prevents it from stopping its forward motion and hitting whatever it's orbiting. So it's kind of a deeper thought there. Think how you want to word that. The question is, you could word the purpose in Van Cleves is demonstrate forces that keep satellites in orbit. The question could be, why do satellites orbit the Earth, or how do moons orbit or how does our moon orbit the Earth, or orbit other planets? So in order to do this experiment, you need a yard of string, which we have measured and cut, so each of you will already have. This is a tutor demonstration only, and you will see shortly why that is. All right, so you're going to tie one end to tape. It can be your painter's tape or masking tape. The idea is that this is a weight, something much heavier than the other end. And you could even, before you get started, or afterwards maybe for effect, you could have them feel how heavy the weight is compared to the other end. So you're going to tie the string to one end. You're going to thread the string through our little bobbins and tie the other end to the spoon. In this tutor demonstration, I'm going to say the tape is acting as the sun, and the spoon is going to represent the Earth orbiting the sun, or the other planets orbiting the sun. You could say, for your demonstration, the tape is going to be the Earth, and the spoon is going to be the moon that orbits the Earth, whichever one you want to do. You're going to, again, have a clear area. In one hand, hold the tape. In your dominant hand, because that's the hand that does the action, you're going to want to hold the bobbin. Up above your head, you get it spinning, and then you let go of the tape. The idea here is that, again, in mine, the spoon is the Earth, and it continues to orbit around the sun, as long as it doesn't get caught up on my hand. And the sun stays in its place. Now, if I stop the forward motion, the Earth is pulled inward toward the centrifugal force that's holding it in the center. Again, if we wanted to say the spoon was a satellite or the moon, and this is the Earth, it orbits. Sorry. Grab your bobbin. It orbits. Once it's orbiting, you let go of the weight, and that shows that this is your centrifugal force in the center, which keeps our moon or our satellite or whatever from flying off into space. So that is number 16, in and out. Our second one for this week is number 13, expanding. This one's a little more simple, but the idea is still kind of deep. To me, as I was just reading through this, it just kind of made me stand in awe of our Creator and the Creator of the universe. This simple experiment is demonstrating what scientists believe, that galaxies, which are groups of stars and planets, that they're always expanding and growing farther away from one another. And so you can talk a little bit about, what is a galaxy? What do they know about galaxies? We know that the Bible says the heavens declare the glory of God. How can they see God in the galaxies and what we're studying today? So the purpose, demonstrate how galaxies may be moving. And again, your question, you could convert that to a question. Do you think galaxies are moving farther away? What have you ever heard about that? Again, for the littles, it'll be as simple as what is a galaxy and do they move? What do you think? What's your hypothesis? So to do this, you're going to have a balloon. I would do probably a tutor demo first, and then if you have time, let the older kids try blowing up their own balloons. The smaller kids will have a problem. You could have each of the parents blow up a balloon for every 2 kids or something. So first of all, you're going to blow your balloon up just a little bit. It says the size of an apple. So just a little bit. Take a black marker or your Sharpie, which will be in your container, and you're going to put stars or planets, whatever you want to make these. They're little black dots all over my galaxy here. Just so they're kind of polka dotted, show everybody, look at my stars and planets. What do you think will happen when I put more air into this galaxy? Do you think the stars and the planets are going to get closer together or farther apart? Let's watch. You will have a mirror per class if you want them to see themselves in the mirror, but I think just even watching you can get the idea without an actual mirror. And you can clearly see they kind of get lighter as they stretch out, but none of these points in space in my galaxy got closer together. They all expanded or got farther apart. And that is the theory of what many scientists believe is happening even now. The galaxies are getting farther and farther apart. All right, have fun with it. Thanks.